We can define motion as a change of an object's position relevant to a reference point. In the case of the ball, in order for me to determine if it's moved or not, I have to use the tree as my reference point in order to determine if it has indeed moved. So I can look at the distance in the first picture and compare it to the distance of the ball from the tree in the second picture, and that helps me determine that the object did indeed move. Okay, so now that we have the definition of motion down, let's go ahead and begin to look at some other vocabulary that will help us with graphing motion. One of the first vocabulary terms that we'll have to learn is the line graph. And the line graph shows change over a period of time. Then we have the slope, which is the steepness of a line. Then you have your x-axis, which shows your independent variable, your y-axis that shows your dependent variable. Speed is simply the distance divided by the unit of time. And then velocity is your speed and direction, and your speed is your distance divided by time and whether you're traveling north, south, east, or west. Okay, so let's look at a few problems that will help us in graphing motion. All right, problem number 1, we have, what do you know about an object that has an average speed of 1 meter per second? First thing we need to do is go ahead and label our line graph. So I'm going to start off with your x-axis, and I'm going to put time down in that section. And then on the y-axis, I'm going to put the variables for distance. Now our time is going to be in seconds, and our distance will be in meters. In this particular problem, I want to find the average speed, and I know that I'm moving 1 meter for every second. So I'm just going to plot those points. I'm going to go up 1 meter, and I'm going to move 1 second. 1 meter, 1 second, 1 meter, 1 second until I see a trend occur. Once I have that trend, I'm going to go ahead and connect all my plotted points into a line. And now I can see what the speed of an object looks like at 1 meter per second. I have a constant rate of change. Okay, so what exactly is a constant rate of change? Well, if you notice, every time I moved up a meter, I moved over a second. Up a meter, over a second, up a meter, over the second. So it just means that that 1 meter per second is telling me that my slope is always the same as I move throughout the graph. So that's why you call this a constant rate of change. It's predictable. We know what's going to happen every time we move up, every time we move over. Okay, so in the last problem, our slope was already given. In this problem, we want to find the slope, and we have a distance versus time graph that has 600 meters for the rise and for the run over 3 minutes of time. So how can we find the slope using this particular information? So now that I've highlighted the things that I need to focus on in the word problem, I'm going to label my graph. You always want to make sure that you label your graphs correctly, and then look at the problem and determine what would be your best intervals for this particular situation. For my time, I'm just going to go up per minute. And now, what would be best for the distance along the y-axis? In this case, I decided to go up every 100 points. And I also try to go beyond what I have on the in the word problem, just to leave myself some additional room. So now that I have the information I need here, I can go ahead and plot these points. I'll find my x value and I'll find my y value, see where they meet. I'll plot my point, and I'll go back from the 0 or the origin and draw my line from there. Now that my line's complete, I can do a few things to determine the slope of the line here. One of the first things that I'm going to do is just do the rise over the run, or divide the rise over the run. And so I have 600 divided by 3. So once we calculate this information, and for those of you that need to see what it would look like, where the values will go when we're dividing, I will continue on here. And so we have that 3 goes into 6 2 times. We bring down our 0, and then we'll bring down the 0 again. And our final answer is 200. So our slope, which is represented in m, is 200 over 1. In other words, 200 meters per minute. So I'm going to go up 200 meters, go over a minute, up 200 meters, over a minute. And again, this is the slope of the line. It has a constant rate of change. Okay, so let's look at our final problem for this video. And we're going to again look for our speed. We have the information that we need, which is the distance and the time. So we can graph this and we can also calculate. So I will show you everything in this particular video or this segment of the video. And we always use the triangle in class, so I'm going to pull the triangle up again just so that we have it handy as we're doing our work. And I already have the graph labeled. So let's go ahead and write down our values, rise over run, which is the distance divided by the time. We can do a few things here. One of the first things I'm going to do with this problem is go ahead and show you what it looks like when we divide it. Okay, so we can see that 20 goes into 30 one time, and then we have a remainder of 10. We're going to go ahead and add our decimal, our 0, bring it down, and now we have 100. And 20 goes into 100 5 times, so our speed is 1.5 kilometers per minute. I could also just say that 1.5 is the same thing as 3 over 2. And another way, an easier way that I could have shown the 3 over 2 was just to go ahead and get rid of the zeros and show you that the slope was 3 over 2 that way as well. Now I've added the arrows to show you that each one is the rise and the run. I know that my line has a positive slope because there's no negative symbol in front of my ratio. So I'm now going to go ahead and plot my points. I'm going to go up 3, go over 2, go up 3, go over 2. Now that I have a few points, I can go ahead and connect them and again show the slope of the line, which has a constant rate of change, which is 3 over 2. So I can say the speed of my car is 1.5 kilometers per minute. Okay, so go back over this video as many times as you need in preparation for this week. And that is all that I have for you today. Bye now.